Good afternoon, everyone. We are the last group to report the solution of ordinary differential equations. We have boundary value, shooting method, and finite difference method. I am Marian Pigingoni. We'll discuss about the boundary value. So we have objectives, define a boundary value problems, solve a boundary value problem given a general solution to differential equation. Now, the first thing we need to do is to define just what we mean by a boundary value problem. A boundary value problem for a given differential equation consists of finding a solution of the given differential equation subject to a given set of boundary conditions. A boundary condition is a prescription sum combinations of values of the unknown solution and its derivatives at more than one point. Kaning nga lesson is naagianan ni nato pag second year first sem, and I know naka-familiar na sad mo ani kung unsaon ni siya. If nakalimot mo, pwede ra sad ni ninyo tan-awon. So, the boundary value problem, a system of ordinary differential equations with solution and derivative values specified at more than one point. Most commonly, the solution and derivative kay nag-specified og mga boundaries or sets of conditions like ingani, y0 is equals to 1, y1 is equals to 3, y0 is equals to negative 2, y2 pi is equals to negative 2. Mga ingana nga conditions, mao na siya. Para masabtan jud nato, let's have an examples.
Hi, I'm Giovanni Abel. For today's video, we're going to show you the solution of ordinary differential equation, boundary value, and sample problems. So as we all know that boundary value problems contains differential equations in a set of boundary equations and evaluated of different points. Alright, let's start with example number 1. Example number 1. Find a solution to the boundary value problem y is equal to y quantity 0 is equal to 1, y quantity 1 is equal to 2. If we know y quantity of x is equal to c sub 1 e over r sub 1 x plus c sub 2 e over r sub 2 x is a general solution to the differential equations. Solutions. R squared is equal to r. R squared minus r is equal to 0. R is quantity r minus 1 is equal to 0. R is equal to 0. R minus 1 is equal to 0. 0 minus 1 is equal to 1. R is equal to 0. Y quantity x is equal to c sub 1 over e 0x plus c sub 2 e 1 over x. E 1 e over 1x. So y quantity x is equal to c sub 1 plus c sub 2 over e x. 1 is equal to c sub 1 plus c sub 2 over e 0. 1 minus c sub 1 plus c sub 2. C sub 1 equals 1 minus c sub 2. 2 equals c sub 1 plus c sub 2 over e over 1. 2 minus c sub 1 plus c sub 2 over e. 2 equals 1 minus c sub 2 plus c sub 2 over e. 1 equals negative c sub 2 plus c sub 2 over e. 1 equals c sub 2 over e minus c sub 2. 1 is equal to c sub 2 quantity e minus 1 is equal to c sub 2 1 over e minus 1. C sub 1 equals 1 minus 1 over e minus 1. C sub 1 is equal to e minus 1 over e minus 1 minus 1 over e minus 1. C sub 1 is equal to e minus 1 minus 1 over e minus 1 is equal to c sub 1 minus e minus 2 over e sub 1. E minus 1 rather, sorry. Y quantity of x is equal to e minus 2 over e minus 1 plus 1 over e minus 1 over ex. The final answer is y quantity of x is equal to e minus 2 over e minus 1 plus e over e minus 1. That's the final answer. Thank you so much for listening.
Good day, I am Florian D.M. Daan. This is the example 2 about boundary value problems. So, determine the solution to the boundary value problem y double prime plus 2y is equal to 0. We're given two initial conditions of boundary conditions. So, y to 0 is equal to 1 and y to pi is equal to 0. So y double prime plus 2y is equal to 0. Since it is equal to 0, let's think about the characteristic equation. So it's r squared plus 2 is equal to 0. So solve for r. So transpose or subtract both sides by negative 2. So r squared plus 2 minus 2 is equal to 0 minus 2. Then r squared is equal to negative 2. And take the square root of both sides. So square root of r squared is equal to square root of negative 2. Since it is negative values, so we will be dealing with the imaginary values. So r is equal to 0 plus or minus of the square root of 2 times the imaginary number. So remembering when we get the imaginary roots of the characteristic equation, so we should do the sine or cosine equating. So our general solution will be y is equal to c1 times 1. So e to the power of 0 is equal to 1 man, so muna 1 cosine of square root of 2 times t plus the c2 sine square root of 2 times t. So boundary condition 1, y is to 0 is equal to 1. So 1 is equal to c1 cosine 0 plus c2 sine 0. So cosine 0 is equal to 1, then sine 0 is equal to 0 mo nang 1 c1 times 1 plus 0. So c1 is equal to 1. So bc2 y of pi is equal to 1. So 0 times 1 cosine of square root of 2 times pi plus c2 sine square root of 2 pi. So transpose nimo ang cosine square root of 2 pi, so mahimong negative cosine square root of 2 pi kana nasa white is equal to c2 sine square root of 2 pi. And then divide both sides by sine square root of 2 pi. So mana i-divide. Then mana nahimong negative cosine square root of 2 pi over sine of square root of 2 times pi is equal to c2. So we all know that cosine over sine is saman cotangent. So mahimong negative cotangent of square root of 2 pi, so equal to c2. Then substitute the value of c1 and c2, so mo ang final answer. Final answer is y is equal to cosine of square root of 2 times t plus cotangent of square root of 2 times pi times sine of square root of 2 times t. So that is the final answer.